So I'm Victor,
I'm Josiah.
and we'll be teaching you inverse trig.
Things that you might need.
Graphing paper, pen or pencil, reading glasses if you need them.
You're so... And a calculator. Alright, this is pre-calc.
So Josiah, today we'll be talking about inverse trig.
But first, let's start with regular trig.
Okay.
Alright.
Let's consult the binder. We'll be using the unit circle in our lesson today. As you can see, I've listed the trig functions that will be positive in their corresponding quadrants. All trig functions are positive in quadrant 1. Only sine is positive in quadrant 2. Only tan is positive in quadrant 3. And only cosine is positive in quadrant 4. To remember this, I use the acronym all-star trig class. All positive, sine is positive, tan is positive, cosine is positive. When talking about the unit circle, cosine refers to the x value, sine refers to the y value, and tan x equals sine x over cosine x when x equals the angle, either in degrees or radians. If you are already in a trigonometry class, these values should look familiar to you. For example, the sine of 30, which refers to the y value, is equal to 1/2. When talking about trig graphs, we use radians instead of angles. To switch from angles to radians, you do the angle times pi over 180. For example, over here, we have 60 degrees times pi over 180 degrees is equal to 60 pi over 180, which reduces to pi over 3, which is your radian value.
Hey, Mr. He, can we draw that sine graph?
Okay, so using the points on the unit circle, we can plot the points on the sine graph. And then we can fill in the curve.
That's so cool.
From this graph, you can determine the domain to be from negative 2 pi to 2 pi. And the range is from negative 1 to 1.
Hey, Mr. He, why don't you draw that cosine graph?
Sure. Using this unit circle, we can also draw the cosine graph and the tan graph.
FYI, he's getting these points by looking at the cosine graph and doing the cosine of 0 is 1, for example, or the cosine of pi over 2 is 0, and so forth.
The domain of this graph is negative 2 pi to 2 pi. And the range is from negative 1 to positive 1. The tan graph is a little tricky because there are asymptotes on every interval of n pi plus pi over 2. So there's one here that I'll draw in. I'll draw in the other ones too.
Now he'll draw the tan graph.
I could keep on going, but the domain of this graph is from negative 2 pi to 2 pi. And the range is negative infinity to positive infinity, because the y values are approaching the asymptote, but they never touch. To take the inverse of a function, you simply switch the x and y values.
Now let's look at some inverse trig graphs.
Essentially, now we're taking the values from the sine graph from negative pi over 2 to pi over 2 and transferring it over to the inverse sine graph.
The reason his graph is going to start to look weird is because since we switched the axes, this graph still needs to become a function. And this is the only way where we can have both positive and negative values while the graph is still a function.
Oh, but Josiah, look over here. From the values of negative pi over 2 to pi over 2, the values are all positive. What are we going to do?
To get the negative values, why don't we just go from 0 to pi?
So, you mean like...
Yep, even though this graph looks weird, it ensures that we get all both positive and negative values into this graph.
Kids, this is super important when you do inverse trig function values. Notice that the range of this function is from 0 to pi. 0 to pi.
Notice how for inverse tan, that the asymptotes actually stay the same and instead are just transferred over. This is key for when we do inverse trig. Notice how for both sine inverse and tan inverse, the range is from negative pi over 2 to pi over 2.
Okay, let's do some practice problems. The cosine inverse of 1/2 is pi over 3, because the cosine of pi over 3 is 1/2.
Isn't that 30 degrees?
No, we're in radians. Remember, the x and y values are reversed for inverse graphs. The sine inverse of 1/2 is pi over 6, because the sine of pi over 6 is 1/2. Ooh, look here. This is a tricky one. Remember what I told you before? Remember the cosine inverse graph. The range of the inverse cosine graph is actually 0 to pi, so negative values fall under the second quadrant. That means the cosine of negative 1/2 is actually 2 pi over 3. Josiah, try the rest on your own, but here's a hint. Remember the inverse graphs and the quadrants they fall under.
Okay, number 4, the sine inverse of negative 1/2. Let's see. Is it negative pi over 6?
It is.
Oh my gosh, look at that. Number 5, tan inverse of 1. Isn't that pi over 4?
Yup.
We're getting closer. Number 6, tan inverse of negative 1. This seems like a tricky one. Let me think about it. Tan and sine inverse have the same intervals on their ranges, which is pi over 2 to negative pi over 2. So in order to get a negative value, you need to be in quadrant 4. So, is it negative pi over 4?
It is.
Oh my gosh, look at that. Uh-oh. Number 7 looks a little hard.
I guess we'll do this one together. Okay, so the cosine inverse of negative radical 3 over 2 is actually 5 pi over 6, if you remember the inverse graph, because it goes into the second quadrant instead of the fourth quadrant.
Oh my gosh, we're done! It makes sense now! Oh my gosh, maybe I can actually pass Miss Messina's class!
If you watch this video countless times,
You might actually have a chance to pass pre-calculus.
good luck.
Have a fun time.
I'm actually kind of hungry right now.
You wanna get lunch?
Yeah, sure. This took longer than I expected.
Stupid kids.